10, 9, 8, 7, 6, 5, 4, 1.
But this video isn't that. I'm making this video to tell you about something I've poured my guts into for almost a year, and it's like the biggest thing I've ever announced on my channel. But first, I have a confession, and that's I love ice cream. It's just objectively the best food that there is. But there's two problems with that. Number one, I have no impulse control to keep me from eating this entire tub in a single day. And number two, other people in my house also love it. So we are competing over a scarce resource. So I came up with an invention to protect the ice cream from my poor impulse control and other people in my house at the exact same time. And here it is. Do you see it? Of course you don't, because that's the first line of defense in action. It's camouflaged in this bag of frozen vegetables. But even if someone in my house were to accidentally stumble upon this bag of vegetables, this is what they'd find. It's impossible for even the world's strongest person to remove this lid, because it's clamped on with a 1/4 ton of force, and yet there are no buttons, latches, or locks. And it works because the lid and the base are made
Assassin ou bruiseur. Quoi faire assassin? Ça risque d'être mort. Oh, assassin Blitzcrank.
Have you met my fleas?
Ça serait très fun. Effectivement. C'est bien des bonheurs là du coup.
Exterminate. Exterminate. I'm on a short fuse.
Fuse is burning, fuse is burning.
Le trait de l'atome.
made from different metals. So you place the carton right in the base, and then the lid just snugly slides on at room temperature. But when I put it in the freezer, the anodized aluminum
Oh, ça peut être extra drôle. Ça peut. J'ai pas dit que ça le serait. Ouais, c'est beau. Pour l'instant, j'aime beaucoup. Il faut un nocturne. Oui, nocturne, ça peut faire 4. C'est dommage. Oui, je suis bête.
lid shrinks 50% more than the stainless steel base does, essentially fusing them together. The trick then is to just run room temperature water over the lid, because when you increase their temperatures, aluminum also grows 50% more than steel. And this solves my impulse control issues because it makes me wait at least 30 seconds to think if I should really eat this ice cream. And in this case, yep, I definitely should. This idea just occurred to me one day, so I made it. And that's the thing I love about being an engineer. If you have an idea about a thing and that thing doesn't exist, you can just will it into existence. So here's my big announcement. I have been secretly working for nearly a year to create a month-long course that will teach you to use engineering and science to bring your own this really cool retro blender I found on eBay that's also just camouflaged in my kitchen, and then it will check to see if I solved it correctly when I turn it on. And if I did, then the back pops open and I get rewarded with my favorite candy, which if it weren't locked away, I would eat every time I came through the kitchen because again, no impulse control. And normally on my channel, whether it's an automatic bullseye dartboard, or the world's largest Nerf gun, or Super Soaker, or a Ninja Warrior obstacle course for squirrels, it's just me presenting the final thing, and then you get to see it in action. But for this class, I pull back the curtain, and you get to see the creation process unfold in real time. You get to see all those aha moments, the hundreds of little decisions that lead to the final build, as I talk you through my thought process and the techniques and tools that I'm using as I use them. But by far the coolest part is you get to practice this process yourself, and that's where the true learning occurs. Together, we'll follow the engineering design process side by side. No matter what your starting skill level is, the course is designed so that by the end of the month, you will leave the class with 3 original creative builds of your own that you can proudly show off to the world. And other students will be in the class with you, so you can learn together and get feedback, and I'll be in there sometimes too, leaving comments and video responses on people's work. And so just to give you a little flavor of the class, here's like a 60-second sneak peek. You guys ready? The first build is mechanical. Here are my 5 requirements now. We want to make sure we have a bunch of different starting points. What's the right arc that this should have? Each time it spun around, PVC pipe here. I don't even know what this is for in real life, but it's small, it's cheap. My work is I'll just raise the back of the catapult up, and that will give me a different launch angle. 3, 2, 1, launch. And then this comes all the way back, and then boop, and it comes down. This makes sense in 2D. Now I've got to take this 2D and like map it to the 3D here. It's a shear load, it's not like a tension load. So that may be enough. You get a force going back that way, goes through the eyelet, and then comes back to me. Captures it, fires, lovely. It impacts on this shoulder right here. It's a dice roll at every gate, basically. So the fewer gates you have, the less complex the system is. The fewer moving parts, always the more reliable it's going to be. Oh, baby! Got it! It's basically like us hanging out together as I walk you through my entire process. In fact, if you combine all the videos in the course, it's longer than the combined time of all the videos I've uploaded to YouTube in my 10 years on the platform. And the goal of the class is not just to expose you to all the tools and techniques that I use, but to teach you to think like an engineer. But like in the good way, not in the way that makes my wife frustrated when we have to talk about feelings. And the process I'll be teaching you is the same process I used at Apple as a product designer. It's the same process I used at NASA to help build the Curiosity rover, and it's the same exact process I use every month on all my YouTube videos. We'll cover mechanical engineering, electrical engineering, 3D printing, prototyping, CAD, Arduino and Raspberry Pi, the scientific method, and so much more, including how to tell a great story around your build and give it character so people will naturally want to share it. And if you hear all that and you're like, psh, that's way over my head, don't worry, because hopefully you trust me enough by now to know that I love to try and take these really complex things and break them down to their most basic elements so that they make sense even for someone just starting out. Now to be clear, if this is your first time dipping your toes in the water, I'm definitely not promising that by the end of the month, you'll be making like fully functioning glitter bombs. But you will have a fundamental understanding of how a mechanical and electrical build like this works, and exposure to all of the steps and processes by which something like this is made. Like there's no element of this glitter bomb that we don't at least somehow touch on in the class. We really tried to design the course so that anyone could create at the edge of their abilities, whatever they currently are. Now, if you're an adult or a professional engineer, I'm confident you will get a lot out of this class. But on the other end of the spectrum, a question I've already been asked is what's sort of the right minimum age level where it won't feel overwhelming? And I'd say for sure anyone like high school or above will be fine. Having said that, I've met some pretty precocious 8-year-olds that are already into building and electronics, and I think they'd be fine too. Otherwise, this is a great month-long activity for maybe a parent and their kid, or even a whole family to tackle together. At the end of the day, if you're not quite sure, you could just sign up to test it out and then get a full refund up until day 5 of the class. The company I partnered with is called Monthly, and they're great. They specialize in these month-long accelerated learning courses, and their user satisfaction ratings are super high across the board. So you can feel confident this would make a great holiday gift, or just a fantastic way to start the new year by making a resolution to learn some new skills that will serve you for the rest of your creative life. So if you're looking for a new hands-on way to bring your creative ideas to life, or if you've always been interested in science and engineering and want to further invest in this interest, or if you're just a more experienced engineer looking for a fresh way to do things, then this class is for you. Just go to monthly.com/MarkRober or use the link in the video description to check it out and then enroll in this month-long learning experience with me. I know what's in the class and I promise you won't regret it.
No one steals my air. I will protect you.
Empire above all.
In exactly 1 week, I'll be releasing. I designed this machine to win the jackpot every time on arcade games like these, where you have to hit the button at the exact moment the light comes by. So the plan was for me to be a hero amongst my buddies and a veritable Chuck E. Cheese Robin Hood giving out free tickets to all the little kids. But that's not what actually happened. It actually turned out way more interesting, and the more I tested, the more I realized this was turning into a repeat of when I used physics to expose the rigged carnival games. Because by building this super precise little robot, I discovered arcade games like this are pretending to be one thing when in fact, they're total scams. Now, in order to explain just how bad they're scamming you, let me first explain how my machine works, and then walk through the results of our testing for the past 2 months. Fundamentally, the way this works is you have a photoresistor right here, and it senses the light 5 or 6 lights upstream of where you need to hit the button to get a jackpot. And then after a pre-programmed delay, the plunger comes down and hits the button. To build this, my buddy John and I started by designing the main base in CAD, and then we 3D printed it overnight. Then we attached the photoresistor at the end of the articulating arm, and then we took a solenoid with a plunger and attached it to the base. It's powered by 20 volts worth of AA batteries, and this is the same power pack I used to trigger the Super Soaker. And the brains of the operation is this wireless Arduino board, and it connects via Wi-Fi to a Super Ghetto app that we made. And the app is critical because it lets you adjust the delay between sensing the light and pushing the plunger. So if you miss short, you just add a few milliseconds to the delay and try again. And then to disguise the whole thing, we put it in a backpack and cut a hole in the bottom so the plunger could access the big button on the machine. So to set it up, you simply walk in, set the backpack down, and then pull out your phone like you're checking dank memes. As you can see, the disguise worked really well, and no one ever suspected anything. So at this point, we were ready for our first real-world test, and the results were disappointing. We were getting jackpots, but only about every 30 tries. And what was so frustrating is we got the timing dialed in so well, we would miss short by 1 light and then not adjust the timing at all. And then on the very next run, we would miss long by 1 light. So for 30 attempts, without changing anything, about half were missing 1 light short and the other half were missing 1 light long. So this could mean only one of 2 things. Either we had some errors in our machine that was introducing some variability, or there was something shady going on with the game itself. And troubleshooting because things don't go as planned is incredibly common when doing any engineering task. So to fix it, you have to systematically do some detective work to figure out where the error is coming from. In the last interview Carl Sagan ever gave, he said,
"Science is more than a body of knowledge. It's a way of thinking."
So here was our thought process. I knew if I could prove that my machine was super precise, then the only reason we weren't getting a jackpot would be because the game is rigged. So I needed to start by looking at any potential sources of variability error in my machine. There were only 3. So it could be the photoresistor, the solenoid, or the Arduino. There was one external source we considered, and that was light pollution from all the flashing lights in the arcade could mean the input to the light sensor was too noisy and therefore not repeatable. Now there's a trick when it comes to troubleshooting where you test several potential error sources at the same time. And if I can get really precise results within this loop, then I know that none of those components are the source of the error, without having to take time to test each individually. So to test all 3 of these at once, we made a simple app that flashed a white screen and started a stopwatch at the exact same time. And then we set the trigger for exactly 1 second later. And sure enough, we were getting results with 1 millisecond precision. We also repeated the test with an incandescent bulb just like the game and got the same super accurate results. Now to appreciate that 1 millisecond of precision, 1 flap of a hummingbird wing takes 12 milliseconds. So 1 millisecond is literally this long. If you pull out your phone and try and get the stopwatch to land on 4.00 seconds, that's really hard, and this is just to 2 decimal places. I had some friends of mine use a timer app that went out to 3 decimal places, which is milliseconds, and then I challenged them to land exactly on 4 seconds. And in 100 tries, these mere humans with their pitiful non-machine reaction times were only able to do it once. Whereas my robot can do it pretty much every time. So there's definitely no error coming from the hardware components, but maybe the sensor is being told to trip at different times because there's so many additional flashing lights in an arcade. And to investigate that, we looked at the signal data from the sensor, which looked really noisy and low like this, until you see a spike in intensity every time the light would come around, which is when the delay countdown would start. Because we had such a narrow field of view on the sensor, when we compared the time between each of the peaks, it was also precise down to the millisecond. So light pollution wasn't the issue either. With this in mind, I headed to a different arcade with some family friends and their kids to see if things would be any different. And we did win a few jackpots. But for the most part, once again, we would alternate missing by 1 light on either side of the jackpot without making any adjustments to my machine, which, as a reminder, can repeatedly hit the same mark within 1/12 of a hummingbird wing flap. And so at this point, it was pretty clear that these games just randomly hand out rare jackpots. But just to be sure, I did some digging and was able to locate a 25-year-old manual for the Cyclone arcade game. And sure enough, if you flipped all the way to the back to page 31, it states the machine owner can specify how often they want a jackpot to be won. Which actually makes sense, because in our testing, a lot of times we'd hit a jackpot right away, and then go through a dry spell until we would finally hit a jackpot again, on average maybe 30 games later. And so in conclusion, my issue here isn't that this arcade game makes money for the arcade owner. My issue is this arcade game presents itself as a winnable game of skill, when in reality, it's a random dice roll that is heavily stacked against you. And if you recall from the Carnival Scam video, the most lucrative games for the Carnival owner are those where people overestimate their chances of winning. That is exactly what happens in this game, especially when you might play a few games and get it to stop 1 light short or 1 light long, thinking you were so close to getting a jackpot, when in reality, you weren't close at all. In gambling psychology, this is known as the near miss effect, and people will spend much more money to try and win because they think they can just do it on the next one. And for that reason, it should come as no surprise that this scam machine is considered the highest earning redemption arcade game ever made. So if I were you, I'd save your tokens for Skee Ball. There's a plunger in the backpack, and then it pushes down on the thing. Is that cool?
So you're basically cheating on
Well, I mean, cheating's a strong word.
cheating!
I'm using an advantage I might have created myself. Thanks for watching.
Following these footsteps.
"11 feet.
Time to start some trouble.
I never compromise.
This is where Draven shines.
Let them try to stop you.
challenge.
I will protect you.
I never compromise.
Let them try to stop me. I will protect you.
My wings are restless.
Rally to me.
They won't survive.
Exterminate.
Run, playfair.
This is no challenge.
leave a dent. I will protect you. Let them try to stop me. Rally to me. Next time, try to leave a dent. I can make a difference here.